Professor Robbert Dijkgraaf. Welcome to my white spot.
Perfect.
I announce you like that because I read your resume and boy. Professor, it's on the screen here at the Institute for Advanced Study. Leon Levy Professor, what does it mean? Could you tell us in one sentence?
Well, I'm directing this institute, but it's a place where people can really pursue their own dreams. So I'd like to say I'm the director of undirected research.
The director of dreams.
Yes, exactly.
But besides that, you also founded proefjes.nl.
Yes.
What is that in English?
Well,
little test.
Little test, but I think the Dutch word proefje is much better. I think because it shows that I think which is the key of science, that you begin exploring. Basically, you're born as an explorer.
Experiment.
Yes.
And you encourage young children with the website to start exploring, and maybe some of them become scientists.
Yes.
But, we thought Robbert Dijkgraaf is the one who is going to tell us the only thing that you should know about light. Robbert Dijkgraaf.
Thank you. Well, thank you also here for curating this wonderful program. And I must say, I feel a little bit like the car mechanic speaking at the end, something, talking about light. And I think the one thing that I want to convey is that light is a unifier. This is the favorite image of one of my heroes, John Wheeler, famous physicist, who said, no, we human beings are like the eye of the universe. It's the universe, after many, many billions of years, formed us here on planet Earth. And we are actually looking at the universe. And we're using light, literally, to look at the universe and understand it. And actually, it's also the U of unification, because I want to tell you about how light kind of has unified so many things in our understanding of the world. And it started already, of course, with Newton, almost 350 years ago, who, as a young man, put a prism in a beam of light and unraveled the light in terms of the various colors. And that was the beginning of a long story. This picture I like very much because it's a heroic image of the discovery of something you cannot see. This is William Herschel measuring the temperature of light outside the rainbow. And he found that the rainbow doesn't stop at red or at purple and blue. It actually continues. He found infrared light, light that we cannot see but we can feel when we feel the warmth of somebody's skin. We are basically measuring infrared light. And I think it's the perfect metaphor. Light is also the perfect metaphor of what science is about. It's an eye-opener. And we look at the rainbow, but then science tells us that the rainbow continues on both ends. This electromagnetic radiation that goes from the very large radio waves to the very short Röntgen and X-rays and gamma rays. And so it's connecting both the very large and the very small in one physical phenomena. That's absolutely amazing. Now these days we can use these different kinds of light using technology to look, for instance, at the moon. It's like we have an artificial eye that can watch the world in infrared or X-rays. And we see something else. This is galaxies. Astronomers study galaxies and all kinds of different electromagnetic radiation. And every different perspective, we learn something new. We also learn about how physical phenomena are identified. There's also beauty in theoretical ideas. And for a physicist, the formula on this t-shirt is the most beautiful thing there is. It's Maxwell equations. It's just a few lines that were found 150 years ago to describe everything you want to know about electromagnetism. And actually, these two portraits are very dear to me. Actually, they're now in my office, but they used to hang in Einstein's office. So Einstein had two pictures in his mind, which were Maxwell and Faraday, the two people who unified electricity and magnetism into one phenomena and made electromagnetism understandable. Faraday, by the way, was also famous because famously there's a story that the Minister of Finance visited his laboratory and asked, "No, what's this all good for, Mr. Faraday?" And he said, "Well, I don't know, but at some point you may tax it." And indeed, we can't really understand our present world, our present technology. 100% of it, I would say, is dependent on electromagnetic radiation. I also want to highlight the work of a Dutch physicist, Hendrik Anton Lorentz, because I would say he had the first kind of idea of the modern view of the world, of reality, being composed of two things, matter and radiation. Matter is our physical bodies, radiation is the way in which these bodies interact. It describes the forces among the bodies, it's the way in which they exert and in which they are connected. So light is a connector between all the physical elements in our universe. And it explains the most basic things in life. Now, if you, for instance, ask any property of any material, say, why is grass green? Till 100 years ago, it just happens to be green. And now we know, no, it's about the way the light interacts with the matter. There is a certain molecule, the chlorophyll molecule, in the leaves of grass that absorbs all the light. It does it very efficiently. But it kind of reflects the green light. And that's why nature is green. Light makes us understand the properties of all materials. And in fact, not only matter, but even space and time. It's the International Year of Light also because it's exactly 100 years ago that another T-shirt was kind of printed. This is the formula that describes general relativity. Einstein found it in 1915, exactly 100 years ago. And we all know E equals mc squared. That is the special relativity, and I hope that this year we learn also the formula for general relativity. And how is it connected to light? Well, in a very deep way. We learned today about how you can shape light, in architecture, in design, in fashion, in art. But actually space and time themselves shape light. Einstein realized that if you put anything, literally anything in space, space will be curved. Space and time will be curved. And the movement through these curvatures are the way we see the action of gravity. And this holds for everything, in particular about light. And in 1990 there was a famous experiment measuring the deflection of light through the sun using a solar eclipse. And these are one of the original pictures of that expedition. And this is the famous telegraph that is now in Boerhaven Museum, and Lorentz sent to Einstein to predict his theory, that his predictions were actually found. And so now we understand that space and time itself, the universe, is basically a big artist. This is with modern telescopes. We can look at the galaxies, and you can see it looks like kind of you're looking at in a funny mirror. Space shapes the light and reflects it in very strange ways. You see many mirror images of a single galaxy in these gravitational lenses. In fact, the universe is using light another way. We now know the universe is expanding, and the way we astronomers detect the expansion is that things that are moving away from us get different colors. The light is shifted. It's the Doppler effect. In fact, some of these galaxies are shifted so far that they are deep in the deep infrared. So the shape of space and time even colors our universe in a very deep way. And it was already mentioned, we can see the light. In fact, exactly 50 years ago, the first light was detected, literally the first light. There was a moment in time in the evolution of the universe that light was first emitted. It was not at the Big Bang, it was roughly 380,000 years after the Big Bang, when matter was no longer so closely tied together that the light could escape. And that light, the first light emitted, we can detect using our telescopes. It's no longer visible light, it's microwave radiation, but it's out there. And we can make pictures of it. And these are these kind of famous pictures. They're these pointillistic paintings that the universe sketched. If you would be able to watch the night sky using microwave eyes, this is what you would see. And this is our very beginning. This is often been described as the baby photo of the universe. And it's kind of amazing it's out there. And in that sense, light allows us to connect, literally, to the very beginning of the universe itself. In fact, we can think of this as the furthest outer shell of the universe that we can look at. And I must say, these kind of modern images of cosmologists, with the Earth in the middle and shells which are further going back in time, reminds us very much of the old pictures in the Middle Ages, where the Earth was again at the center. We had various rings of planets and stars surrounding it. But this time it's not in our imagination, it's actually the science that's giving us. And it's beautiful that we can see it and study it. In fact, we might do even more. We might hope that there is even another way to detect things and make contact in the universe. We know light travels, it's a wave, it's a particle. We think that gravity can also be a light, like light, and can travel and there can be waves. And if this is true, this will be looking in the future. We might even see more in the universe. In fact, the universe itself, when it began, it was some kind of a quantum chaos. And this is really literally at the very beginning of the universe. And we might be now at a stage where we can even see that. We can, by carefully looking at the light emitted, we can detect these very primordial fluctuations out of which the universe was started. I must say it's very important to stress that all of that research is just happening these days. We are all extremely fortunate. Not only that we can look back and we can look in the future, but we also can live in the present. Actually, it's right now that these amazing stories of the universe are being discovered and understood. And we have now a wonderful image of how we think of the universe. We know that at the smallest distances, space-time might be in some chaotic quantum statement. And at the largest distances, we see the universe as a whole. And what I always find very beautiful, that right in the middle are we. I mean, that's the scale of life, the scale of a bacteria, or of us. And if you would go to 1/4, you're roughly at the size of the moon. That's how far human beings traveled. If you go 1/4 in the other direction, you find the distances that particle accelerators explore. So we kind of physically have mapped out a large part of that universe. And there are really exciting ideas around these days that perhaps we can see and we can think of the universe as being created out of these very small things, which are the smallest distances that we can imagine. There's a physical theory called inflation that tells us that we ourselves are a miniature speck of space that has been expanded to gigantic dimensions. And so literally the smallest scales and the largest scales are unified. Not a fairy tale, but a physical theory that can be tested. In fact, it's being tested right now. This is a famous laboratory on the South Pole, the BICEP laboratory, that was in the news last year because they detected this first light emitted just after the Big Bang and looked at the polarization of the light. Now, just as with the Polaroid lens, you can see the light, for instance, reflected from water, being different if you turn your glasses around a little bit. In the same way, there could be kind of swirls or fluctuations in this pointillistic painting that are a signal from the very beginning of the Big Bang. And so that's actually a measurement. They thought the measurement was there, now it might not be there. They keep looking, other experiments are looking. But we should realize that, how far we have come, that, going back to my original picture, that we are looking at the universe, we are understanding the universe, and we might be actually going back to the very beginning. And I think it's absolutely amazing. People always thought, distances far away, you can never travel there unless you're in a science fiction movie. We can never make contact with worlds which are billions of light years away. Till we realize we can, yes, because something is traveling to us. It's the light. It's the light that is connecting all parts of the universe. It's kind of at the same time our biggest telescope and biggest microscopes using light. And it's actually unifying all the physical phenomena. And so I would we saw a lot of kind of beautiful ways in which human beings, you, architects, designers, artists, shape light. But I think actually the universe itself should also be appear here as an artist, because I think actually nature is almost as imaginative as we are. So thank you very much.